Good day, everyone. I am very delighted that we are here to learn something new once more. So, without further ado, I am Jody Samora, along with my group mates, presenting the carbohydrate sequence in human blood.
Before going further, let's take a look at the discovery of human red blood cells, or simply called erythrocytes. An Austrian-born American biologist named Carl Landsteiner, he found out that when the blood was milk, the blood cell sometimes clotted. In 1901, he explained that people have different types of blood cells. Then this discovery led to blood transfusion between people with compatible blood groups. The human blood. Carbohydrate chemistry is one of the great importance for the most commonly considered blood classification. ABO is the best known system for grouping blood types, though there are other methods. And here are the four major categories: A group, B group, O group, and AB group. The blood types are named after antigens that are found in the surface of the red blood cells, and these antigens are simple change of sugar. And the picture of my right side is showing the blood group and the antigens on the red blood cells. Here is the things that need to remember in determining blood types. First, the antigen. Any substance that induces the immune system to produce antibodies against it is called an antigen, while the antibodies are specialized Y-shaped proteins that bind like a lock and key to the body's foreign invaders. So, both of these, the antigen and antibodies, interact with each other, and it is the key in determining a person's blood type.
In determining a blood type, we can simply know what antigen is present in the surface of the red blood cells. If we have an A antigen, we can conclude that we have an A blood type. If we have B antigens, we can determine that it is a B blood type. If we have AB antigens, we can determine it's an AB blood type. And if there is no antigens present in the surface, we can consider it as a O blood type. In transfusion, we can determine what blood is compatible by knowing the antibodies in which it interacts with the antigens. For example, if we have an A blood type, we have anti-B which interact with what blood type? Of course, it's type B blood. So if a type B blood comes to an A blood type, the anti-B will destroy the B blood type. So we can determine if it is compatible for transfusion, and we can simply interpret it by matching it depending on a certain antigen or antibodies. So then it is not compatible unless it is a AB blood, which is considered a universal recipient because they do not have antibodies.
So for the continuation of that topic, I'm going to discuss about blood types and carbohydrates. So all people synthesize a precursor carbohydrate called the H antigen, which is attached to lipids or protein on the other surface of red blood cells. Specific enzyme synthesized by the EBO genes attach at, attach additional monosaccharide to the H antigen, and the complete carbohydrates determine the person blood types. There are many blood groups in the human population, including ABO, RH, KID, KIL, Duffy, MNS, and Lewis. But the most important thing of these are ABO and RHG. Um, the carbohydrate is built around core of 5 to 30 sugars called the H antigen that end on a fucose sugar. Um, each antigen is a precursor to each of the ABO blood group antigen, apparently present in all people except those with Bambi blood phenotype. Um, histo- histocompatibility antigen, a major factor in Greek rejection. Um, the ABO blood group antigen are attached to the oligosaccharides chains that project above the RBC surface. These chains are attached to proteins and lipids that lie in the RBC membrane. The ABO gene indirectly encodes the ABO blood group antigen. While blood types may be considered a biology or medicine topic, carbohydrate chemistry is a great of importance for the most commonly considered blood, blood classification, the BO blood types. So in this slide, this is the structure of the blood group. So um, the blood type result are depends on the chain. For example, um, if the chains end up in acetic acetyl galactosamine, which mean is an antigen, which you can later conclude to be an A blood type because red blood cells are surrounded by A antigen on the surface area. But take note, since both A and B are genes are presently in AB individual, some each antigen get an in acetyl galactosamine residue while others get a galactose residue. So Rh factor or rhesus factor is an important characteristic of blood cells. Now it is an antigen occurring on the blood cells of many human. Um, there, there, there are more than 40 different kinds of Rh antigen, but the most significant Rh is Rhd. When Rhd is present on the rhesus surface, the red cells are called Rhd positive, and antibodies to Rhd develop only after an individual exposed to Rhd antigen via transfusion, pregnancy, or organ transplantation. Um, so if you are, and also if you are Rh positive, then you have Rh plus positive antigen on red blood cells, but you can make an antibodies because they will attack your blood. And if you are Rh negative, then you don't have any you don't have an Rh antigen, and your body can make antigen to the Rh plus antigen. People who are Rh plus positive can receive Rh positive or Rh negative blood because they don't have any antibodies to attack the Rh antigen. People who are Rh negative can only get Rh negative blood because their Rh positive antibodies will destroy any Rh positive red blood cells. As a general rule, Rh negative includes should not be transfused with Rh positive red cells, especially Rh negative girls and women of childbearing age. If transfusion of an Rh positive product to Rh negative recipient is unavoidable, a hematologist should be consulted and administration of an anti-D immunoglobulin considered. So these are the red blood cell contability table. Um, so when you are blood type A, what um you're telling the people is that the cell in your body make antibody only to type B antigen. The type A surface antigen of the cell are not recognized. The surface antigen can be affected to the surface of blood to your blood cells or to proteins or lipids anywhere in your body. So if you are blood type B, the situation will reverse. Your cell have type B antigen attached So your body can make antibodies against only type E. Once the type E antigen are kept at bay, your blood can show type B as a dominant type. If you are AB, your cells do not make antibodies against type E or type B surface antigen. Therefore, you can receive blood from a donor with any blood type. Um, is a it is a universal recipient, but you can donate blood only to other people with type AB blood. If you are blood type O, your cells make antibody against both type A and type B antigens. This means if you need blood, you can only receive more type O blood, but you can donate your blood to anybody. Thus, you are universal donor. Type Type O blood is the most common blood type.
I'm quite sure that every one of us have heard corn syrup. What we are about to discuss next is related to that, in which is high fructose corn syrup. Now, let us learn more about it in the following slides.
A brief history of HFCS. HFCS is short term for high fructose corn syrup. In 1957, Richard O. Marshall and Earl R. Coe produced the first HFCS after they created the enzyme glucose isomerase. This enzyme rearranged the composition of glucose in corn syrup and made it into fructose. The production of HFCS. High fructose corn syrup is a liquid sweetener made from cornstarch. It is made by breaking down corn into molecules of glucose. Half the glucose molecules are then chemically changed into fructose. The production of high fructose corn syrup is processed of catalytic reaction of enzymes. Three enzymes are amylase, glucoamylase, and glucose isomerase. This is the concept map of our cornstarch. When the cornstarch from the endosperm is physically isolated from the rest of the corn grain, it then heated and mixed with the amylase to hydrolyze the cornstarch to dextrin and oligosaccharides, which are easier for breakdown. Then, the dextrin and oligosaccharides are converted to simple sugar by enzymes glucoamylase. Finally, the catalytic reaction of enzyme glucose isomerase converts glucose syrup to fructose syrup, 90% fructose and 10% glucose. The products of HFCS42 is 42% fructose and 58% glucose, and HFCS55 is 55% fructose and 45% glucose. It can be obtained from further processing of HFCS9P. Chemical structure. This is the formula of glucose. And the classification of HFCS is a mixture of two monosaccharides. 50% of fructose plus 45% of glucose is equal percent of 100% sucrose. Basically, it is a disaccharide sugar, as we can see for our structure.
High fructose corn syrup nowadays has crept into more of our foods over the last few decades. Compared with regular sugar, it's cheaper and sweeter, and it's more quickly absorbed into your body. High fructose corn syrup can be found in canned fruits, boxed desserts, flavored yogurts, baked goods, breakfast cereals, and condiments like ketchup, jams, and jellies. So, what are the pros and cons of high fructose corn syrup? So let's start from the pros. Number one, high fructose corn syrup prolongs the shelf life of foods in which it is used. Number two, the corn from it is derived is abundant and relatively inexpensive. Three, high fructose corn syrup is economical for the companies that produce processed foods because it is much cheaper than sugar. Four, it is cheaper and less labor intensive to manufacture than sugar. Five, when used in food products, it imparts freshness and textures and can take the place of some types of preservatives. 6. It dissolves in water quickly. 7. In food that we need to be browned or that benefits from crunch, it performs better than sugar. So what about cons? Number 1. It adds an unnatural amount of fructose to your diet. 2. Increases your risk of fatty liver disease. 3. Increases your risk of obesity and weight gain. 4. Excessive intake is linked to diabetes. 5. Can increase the risk of other serious diseases. 6. Contains no essential nutrients. And 7. Insulin resistance.
Thank you for watching. For further questions, feel free to write it down in the comments below.